Welcome to Mimi's Math Channel. Today I'm going to discuss the final exam review using Desmos for exponential growth and decay. So in our class, we are used to seeing the formula written as A is equal to P times the quantity of either one of these. So it could be 1 plus R, 1 minus R, so on and so forth, raised to the T power. However, sometimes you see the formula that looks like this, where Y represents your A or your A of T, A represents your P, B represents those quantities that I mentioned before, or if you see the word doubled, you would replace B with 2. If you see the word tripled, you would replace B with 3. And then X is usually shown as a T, which represents time. But when we're using Desmos, we don't want to use T. We want to use X and Y. So for our first example, as you're reading through it, you want to identify what goes with what. If it's more comfortable for you to use the A and the A of T, P, and so on and so forth, you can do that and label it over here. But for this video, I'm going to use the A, B, Y, and X. So for A, that's going to be my principal, my initial, what I started with. In this example, I purchased a cell phone for $125. So that's what A represents. The value increases, so it means that we're going to use the 1 plus R method. R meaning your rate. Once you see your percentage, you want to change that to a decimal. So I'm going to take this and move it back 2 places and put a 0 placeholder. So that looks like this. Because I said increases, I'm going to put a plus sign. And simplified, that's going to be 1.07. The question is asking you how long. So that means the variable X is what you're trying to find. But how long does it take you to before it cost approximately $155? So that's a future amount. So that's going to be the Y value, 155. So this is important to know because once I go to Desmos, I can just go ahead and put Y equals what's on this side of the equation in this example. So that's going to look like Y equals 155. And then once I look at the right side, I am going to take all of this, including raising it to that X, and I'm going to put it in its own separate row. What I will notice is I have I have two different graphs. I have a red and a blue. If I do not put this Y equals here, I don't have a graph. And then that way it's kind of hard to find what I'm looking for. So I have to put that Y equals whenever I don't have an X in the row that I'm looking for. So if I don't see this graph, what I want to do is just use my zoom functions, and I'm looking for what X would be when Y is 155. So that's why we want to use X and Y's. So I see the blue, and now I see the red. And if I need to get a clearer picture, I'm just going to click where they intersect. When Y is 155, X is 3.17936. Let's go back to our directions, which ask us to round to the nearest year. So that 3 is the nearest year is just going to be 3, since 0.1 is not 5 or higher. So if I go to my next example, I'm going to do the same thing. I'm going to read through it and look for data and then try to label it based off of the variables that are shown in my formula. I see the years 1983 and 2003, and I'm told that in 1983, there were a certain amount of bats. So I know this is what I initially started with. So that's going to be A or P. And that number decreased. So that's going to be B, which is really 1 minus the rate because I'm decreasing this time. And the rate is 11%, which I have to change to a decimal. So that's going to be 0.11. And once I simplify that, that's 0.89. So over here, I have A times B raised to the X power because I'm trying to find how long that it's going to take for the bat population to be half the initial population. So now here you have to be careful because you're like, well, where did this come from? It's at half of the initial population. The initial population was this. So that's where Y is coming from. Now that I know this information, Y equals this amount, I can go to Desmos and I can type in Y equals that amount. And then to the right, of my equal sign, I can type this in on another line in Desmos. I see that I have my graph icon, so now I'm going to go over and see where they actually intersect. And because those are large numbers, it may take a while to zoom to where they both intersect, but it's there. You just have to keep zooming. Here we go. And again, if that's too small for you, you can make it bigger again. Click on it and verify that your Y is the amount that you said. And what is X? We're looking for X. When Y is that? And if we go back to our directions, this time it asks us to round it to the nearest hundreds. So 5.948 is really 5.95. So that's what the answer is for that, part A. And then the last example, you're asked to round to the nearest whole number what the bat population would be in 2003. Well, you were given 2 years, so you want to take the latest year and you want to subtract it from the earliest year, and that left us with 20. 20 represents X, which is our time, and that's our exponent. But we're trying to figure out what the actual future population will be. So this is an easy one because we don't have to put y equals. That's what we're trying to find out. We only put this side, but we replace that x with 20 now that we know the year. So we're going to get rid of this because y is not going to be that. And we're going to replace this one, and you're going to have to make sure it's an exponent, because if you just type in 20, well, in this case it worked, but sometimes if you just type 20, it'll make it big. So make sure that it's an exponent. And we can't have a 0.87 bat. So we're going to round this to the nearest whole number. And since the number after the decimal is bigger than 5, we're going to add 1 to the number in front, which gave us 13,729 bats. All right, so that is how you use Desmos when you are dealing with exponential growth and decay. Thank you for watching, and please remember to like and subscribe. Have an awesome day.